Our next lesson is called Angle Sum of a Triangle and Exterior Angles of a Triangle. For the opening exercise, it says answer questions number 1 through 5 to prove that the sum of the degrees of the interior angles of a triangle is 180 degrees. So again, you're trying to prove that the sum, which means when you add, of the degrees of the interior angles of a triangle, that means the angles on the inside, are actually equal to 180 degrees. Now you're going to be working on questions 1 through 5, but I would like to label the rectangle together. So in the top left corner, we're going to label A, and then we are going to label clockwise, B in the upper right, C in the lower right, and D in the lower left. This will help us be consistent when we're going over the answers to this activity. So at this time, I'd like you to pause the video and complete the opening exercise, and then resume the video when you're ready to go over the answers. Okay, now that you've had a chance to try the opening exercise, let's go over the questions together. So you're starting with a rectangle, and they wanted to know what was true about the 4 angles of a rectangle. So all 4 angles are congruent, and they are 90 degrees. So you can see in my diagram, I labeled all 4 angles with a box indicating that they are 90-degree angles, all in green, showing they are all the same. Then in question B, what is true about the sides of a rectangle? Opposite sides are equal in length. So in order to show this on my picture, if you look at my diagram, in a previous chapter, we talked about how to add tick marks and arc marks to show which sides are the same. So in my diagram, from A to B and from C to D are the same length. They're opposite sides. So I gave them both 2 tick marks to show that. And then AD and BC are the same size. So I gave 1 tick mark to show that. So in starting to try to prove why the angles of a triangle add up to 180, we look at the next question. I wanted you to draw a diagonal that connects A to C, and honestly, we could have done this using B and D instead, but I wanted to know what shapes were formed. So the shapes that were formed were 2 triangles. Now, I need to know if these triangles are congruent. So remember, anytime I want to prove if something is congruent, I can use transformations or sequence of transformations involving reflection, translation, or rotation, any combination. And as long as I can get one shape to the other, to map to the other, with a single or combination of those 3, I'm going to have congruent figures because reflections, translations, and rotations preserve side length and angle measure, which means they create congruent figures. So if I look at this picture and I choose maybe triangle ADC, I can take that triangle and turn it upside down, so that would be a rotation 180, and then translate it to land on top of ABC. So I wrote yes, rotate 180 degrees, and translate to the right to map one onto the other. So that tells me not only do I have 2 triangles, but I have 2 congruent triangles. Then I wanted you to say, okay, so now that we know that, what's the angle for the original sum of the interior angles for the rectangle? So if I look at that, that was 4 90-degree angles. That means a rectangle has an interior angle measure total of 360 degrees. So naturally, since the rectangle is made up of 2 congruent triangles now that we know, that means each will have exactly half of the total degrees of the rectangle. So if we had 360 for the rectangle, if we cut it in half, that's 180. So we just proved that each triangle has an angle sum of 180 degrees. So that means if I ever have a picture of a triangle in front of me, I know that the 3 angles inside the triangle should add up to 180. That could be simple math, like I know one is 20, one is 40, I find the missing piece. That could also be applied in expressions. Maybe I have x and 2x and 3x. Well, x plus 2x plus 3x would equal 180. I could find x and therefore find any of the measures of the angles. So at this point, I would expect moving forward, if you see a picture that involves a triangle, you can use your knowledge that the 3 angles of the triangle, interior angles, are always going to add up to 180 degrees. Now, the second part of today's lesson wants to look at what are called exterior angles of a triangle. So now let's look at what is called the exterior angle of a triangle. An exterior angle is formed when one of the sides of the triangle is extended. So you can see here in triangle 1 that if I take this bottom side and I extend it, this is the exterior angle, the blue. Similarly over here, if I extend this line, it's this blue, 67 degrees, that would be considered the exterior angle. So I'm wondering, do you notice a relationship between the exterior angle and the remote interior angle? So let's talk about remote interior. When do you use a remote? Oh, I know, I'm on the couch and I want to change channel and I don't want to have to get up to do it. I use my remote. So that means I'm far away from what I need to get to. So remote means you're far away and on the inside. So remote interior angles would be 80 and 40 in triangle 1 and 40 and 27 in triangle 2. They're all the way on the other side of the triangle inside. They're not touching the exterior angle at all. So do you notice a relationship? If you look at triangle 1, if I look at the exterior angle, it's 120 degrees. If I look at the remote interior angles, that's 80 degrees and 40 degrees. What would be the relationship between them? Well, 80 and 40 add up to 120. Does that same thing happen in triangle 2? The remote interior angles are 40 and 27. They add up to 67. So it looks like that's what's going on. So the exterior angle is equal to the sum, so remember sum means to add, of the remote interior angles. So now let's talk about why does this even work? So the sum of interior angles of a triangle we just talked about. The sum of the interior angles of a triangle now are 180 degrees. And then if we think about what a straight angle is, so I'm talking about if you have a straight line on your paper. We just talked about this in a previous lesson. How much is that worth? Well, that's also 180 degrees. So because of that, we can reason our way through explaining why this always happens. So let's look at triangle 1, the triangle sum. Inside the triangle, we have 80 and 40, which is equal to 120 degrees. If I wanted to find the third angle, this one right here that I'm just putting in green, then I would have to take away 120 from 180 because they're all supposed to add up to 180. And I would end up with 60. Okay, so that means this would be 60 degrees. If I look at it from the straight angle perspective, so in green you can see there's my straight angle. I know that a straight angle is supposed to be 180 degrees, and I already know the exterior angle is 120. So if I subtract those, I also get 60 degrees. So that tells me that since they both ended up equaling 60, that 120 is equal to the 80 plus the 40. So in other words, the exterior angle is equal to the two remote interior angles added together. Does that also now work in triangle 2? Let's take a look. The triangle sum, we had 40 plus 27, which was equal to 67. The three angles of a triangle are supposed to add up to 180. So I would do 180 minus 67 to see that that would be 113. Now, if I look at it from a straight angle perspective instead, I know that a straight angle is 180, and I already know that angle on the outside, the exterior angle is 67. So if I subtract those, I get 113. I get the same answer. So because I get 113 for both, that means the 67 is equal to the 40 plus the 27. So once again, the remote interior angles add up to equal the exterior angle. So as a final, the exterior angle theorem says the measure of an exterior angle of a triangle equals the sum of the remote interior angles. So let's show how we can actually use this to answer questions, okay? So there's two ways we can answer a question like this. We can now use our new exterior angle theorem. I would look at the picture and I would say, okay, X is my exterior angle, and that makes 36 and 75 my remote interior angles. So according to my theorem, my exterior angle, which is X, should be equal to the sum of my two remote interior angles. So that would be 75 plus 36. So that means X is 111 degrees. Option 2 would be to use triangle sum and straight angles. So I can look at this like it is a picture of a triangle. A triangle has interior angle sum of 180. So I'm going to take the 75 and the 36 and add them up, and I get 111. I can then take that 111 away from 180 to see what the remaining angle of the triangle is, and that would be 69 degrees. And now, using the fact that these are a straight angle on my pink line, I can take 180 and subtract the third angle of the triangle to see that my answer would be 111 degrees. So you can use either method. Although you can see the benefit of using the exterior angle theorem, it's much shorter. And that concludes our lesson on angle sum of a triangle and exterior angles of a triangle.